Hello. If we want to change the impact that transport has on our planet and on our environment, the first thing that we have to do is understand the current situation, why transport has such a high impact. We will see in this chapter that is related with the kind of fuels that we are using. And the question is if that we have to know the characteristics of these fuels if we want to change it by another source. Well, let's start this chapter by analyzing what is a vehicle. A vehicle is a machine that is using the energy that is stored in a fuel and transform it into something, another kind of energy that is the kinetic energy of the vehicle. If we analyze the kind of fuels that we use, we will see that mostly all of the fuels that we use in transport are derived from oil. There are other kinds of energy sources, like for example electricity, methane, but the most used fuel that is used in transport are derived from oil, are gasoline, diesel, this kind of liquids. So the first thing that we have to do is understand why. So why gasoline or gasoline-like fuels are so used in transportation? Why are that kind of fuels so ideal for using in transport? And in this chapter we will see the properties that makes these fuels so ideal. There are these two, the heat of combustion and the power of combustion. These two properties makes gasoline a very good fuel to be used in transport. On the other side, we know that the level of emissions of using this fuel is so high, so this is an undesirable property. Well, in this chapter we are going to study these three properties, and we are going to see which are the magnitudes that we can use to describe these properties. Well, let's start by the first, the heat of combustion. The heat of combustion is the amount of energy that is released when we burn 1 kilogram of some substance. If we take a look at the historical energy sources that as a society we have used, we can see that gasoline is at the top, almost at the top. So when we burn 1 kilogram of gasoline, we obtain 47.3 megajoules of energy. If we compare this with some kind of coals, like for example lignite, we will see that gasoline is so high. So lignite only gives us 15 megajoules of energy. This is very low compared to gasoline. And why is this property so desirable? This is because when we move, we carry with us our fuel. And with a very low heat of combustion, this would mean that when we move, we would need to carry with us a lot of fuel. Gasoline has a very high heat of combustion, and this means that with a very low amount of gasoline, we will be able to obtain so much energy, and this would mean that we will be able to do a large distance with that combustible. So at the end, the autonomy of the vehicle is related with the heat of combustion of the fuel that we are using. And this is the first reason why gasoline is so used, because it gives us so much autonomy in our vehicles. The second property is it depends on the speed that we want in some cases, in some situations. When we want to pass another vehicle, for example, or when we drive in our highways, we need a lot of energy in a tiny amount of time, and this is what power is used. The power is the quotient between the energy that we are using and the time, the period of time where we are using that energy. If we need a lot of energy in a tiny amount of time, this means that we need a very high power. On the contrary, if we use a low amount of energy into a large period of time, we need a very low power. This is what it's done in our motors. When we combine gasoline with oxygen in the proper combination, this combustion can be explosive, and that's the reason why it can give a lot of power. And this is the characteristic that this is the second characteristic that makes gasoline so ideal to be used in transportation. Is the large power that it can give the combustion of that substance. Okay, now let's study the worst of the properties of these fossil fuels, that they emit carbon dioxide, and let's study how to characterize the different fossil fuels. All the fossil fuels are molecules, combinations of molecules that are composed by carbon and hydrogen, basically. That's the reason why they are called hydrocarbons. And the combustion of these molecules are the redistribution of these atoms to obtain finally carbon dioxide, that is the combination of the carbon with oxygen, and water, that is a combination of hydrogen with water. Obviously, water is not dangerous for the environment, but carbon dioxide is a dangerous molecule because it's responsible for the greenhouse effect, and we want to characterize the different rate of emissions of the different fuels. And the correct way to do it is by studying the emission factor. What does it mean? It means the amount of carbon dioxide that we get if we obtain 1 megajoule of energy. It's important that you notice that it's not done in terms of the amount of mass that we burn, because the different fuels gives us different amount of energy, and as the final goal of burning these fuels is obtaining an energy, the important magnitude is how much carbon dioxide we emit by obtaining the amount of energy that we want. And if we compare the different fuels once again, we see that in the case of gasoline, the amount of carbon dioxide that we emit is lower, for example, than wood or coal. Coal is a kind of combustible that emits a lot of carbon dioxide, while gasoline it's not so high. Let's look for the reason. We studied in the previous example the case of methane, that it was the simplest of the molecules. But if instead of this molecule we use butane, that is the combination of 4 carbon atoms with 10 hydrogens, we'll see that we obtain once again carbon dioxide and water, but the amount of the two molecules is different. In this case, we obtain for a single butane molecule 4 molecules of carbon dioxide and 5 of water. If we compare the combustion of methane with the combustion of butane, we see that in the case of methane, we obtained the double of molecules of water than carbon dioxide, while in the case of butane, we obtained the same amount of carbon dioxide than water. And that's the reason why in the combustion of the different fossil fuels, you obtain different levels of carbon dioxide, because the amount of carbon and hydrogen that these hydrocarbons has is very different. For example, in the case of coal, we have a low amount of hydrogen. Most of the molecules are simply carbon. While in the case of, for example, natural gas or gasoline, the abundance of hydrogen and carbon are more balanced. That's the reason why even different fossil fuels give different levels of contamination. And that's also the reason why there are some regions where they are replacing coal by other kind of energy like natural gas, and in this change we obtain an improvement in our impact. So the reduction of the emissions can be done also changing the kind of fossil fuel that we are studying. Okay, now that we know the properties that our fuels has to have in order to be used in transportation, we know how to do this green transition. So we need fuels that can give us a very large heat of combustion and a very high power of combustion, but reducing the emissions that we get from combusting these fuels. So this is the work that has to be done in order to make this activity, the transportation, less harmful for our environment. Okay, in conclusion, we have seen that most of the fuels that we use in transportation has two very good properties that are a very high heat of combustion and a very high power of combustion. And in order to make this activity less harmful for our environment, we need to obtain new energy sources that can give us the similar properties that these fossil fuels are giving us, with a lower level of emission.